In question 8, we have two functions f of x and g of x. It is given that in part A, f of 7 is 5 upon 2 and g f of 5 is equals to 4. We have to find the values of a and b. Now, f of 7 means in the function f, we'll replace the x with a 7. So this will become 7 minus a and put it equals to 5 upon 2. We can take the LCM over here, which will make it 7 minus a plus 2a upon 7 minus a is equals to 5 upon 2. So minus a plus 2a is 7 plus a upon 7 minus a, which is equals to 5 upon 2. Cross multiplying, we'll get 14 plus 2a equals to 35 minus 5a. Bringing the 5 on this side to make it a 7a equals to 35 minus 14, which is 21. So 7a is equals to 21 and a will be equals to 21 upon 7, which is 3. We have been also given that gf of 5 equals to 4. So first we'll find g f of x. So to find g of x in the function g, in place of x, I'll replace the function f. And as we already have the value of a, we can write this as f of x is equals to 1 plus 2 times 3 is 6 upon x minus 3. So this will become 1 plus 6 upon x minus 3 minus 2. And as it is given that g f of 5, it means in place of x, we'll write 5 and put it equals to 4. So we'll write it as b into 1 plus 6 upon 5 minus 3 minus 2 equals to 4. So 6 upon 5 minus 3 is 2. So this will become 3. So 1 plus 3 minus 2 equals to 4. This will become 4b is equals to 4 plus 2, 6. b will be 6 upon 4. And we can simplify to write it as 3 upon 2. Now in part B, it is asking us to find the domain of f inverse, and we'll be using the value of a which we found in part A. So f of x was 1 plus 6 upon x minus 3. So as f of x is equals to 1 plus 6 upon x minus 3, to find the domain of f inverse, we'll find the range of f of x, as the domain of f inverse will be the same as the range of f of x. Now we know that x will be greater than a, and as a is 3, so we can write it as x is greater than 3. It had been given in the question initially that x is greater than a. Now to find the range of f of x, if I substitute any value greater than 3, we will find that the f of x will always be 1 or more. So if I substitute, let's take a value of x as 3.0001, which is greater than 3. If I divide by 6 upon 3.001 minus 3, it will be 0.001. We'll get a very large value for f of x. And even if we take a very large value in place of x, so let's say if I take a value of x as 100,000 or whatever I want to take, 1 plus 6 upon this value minus 3, it will be near 0, but it will always be greater than 1. So the range of f of x will be greater than 1, which means that the domain of f inverse will also be greater than 1. Now in part C, we have to find an expression for f inverse of x. To find an expression for f inverse of x, we'll simply write y in place of f of x in the first step. In the second step, we'll replace y and x. So this will become x equals to 1 plus 6 upon y minus 3. Taking 1 on the other side, this will become x minus 1 and then equals to 6 upon y minus 3. As we have to make y our subject, we'll write it as y minus 3 is equals to 6 upon x minus 1. Finally, taking 3 on the other side, this will become y equals to 6 upon x minus 1 plus 3. We can write a final answer as f inverse of x is equals to 6 upon x minus 1 plus 3.